Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and this is going to be the first of a two-part series on how weather observations, actual observations of real data, are taken at various places around the world, and how that information is coded and then sent to us users like myself to try to make some sense of it. And back when I was at Penn State, just after the last T-Rex had died, we had a slightly different code that we used. It was called the Surface Airways Code, and it had a lot of similarities to the current code, but there were a few differences. But back then, we didn't have computers to plot the maps for us, so we would all fight. All us nerds up there would fight over who was going to plot the map for this hour. And so we had a blank map, a whole bunch of blank maps that went from about the East Coast out to maybe the High Plains. And then we would put the sheet of paper, which came off a Western Union teletype, okay, which is like a typewriter hooked up to data. You can see the little keys going, carriage return, like that. And then we would put that piece of paper next to the map, and we'd say, okay, there's Boston, write down all those numbers. There's New York, write down all those numbers, and so forth. And it took about an hour to do all of that. And to draw in the isobars and the precip areas and all that sort of stuff. But we thought it was fun because we didn't have a life. Okay, so let me put myself down here in the corner and show you a sample weather observation from the RDU airport about 9 minutes before 8 o'clock this morning. So obviously the KRDU is the Raleigh-Durham Airport. The K basically tells you what part of the world these observations are from, and all the U.S. observations start with K, and then the RDU stands for the RDU Airport. Some of those three-letter identifiers, and this is what you would see on your luggage if you were, flying to RDU. You would, have your little luggage tag, and it would have RDU on there. Most of them you can figure out, but some of them are weird. Like North Platte, Nebraska, is LBF. What does that stand for? That stands for Lee Bird Field. Apparently there was some dude named Lee Bird that was famous in that part of the country, and so they named the airport after him. But if you didn't know who Lee Bird was, you'd never be able to guess that. So anyways, so let's move on ahead here. So we have this first group of numbers, 23151Z. The 23rd is the date, okay? The 1151Z stands for 11:51 Greenwich Mean Time. Okay, that is the standard time that is used for everything in meteorology. And then local time is Greenwich Mean Time minus 4 hours. So this time of year. So 11:51 minus 4 is 7:51 a.m. Eastern Daylight Time. Now, if daylight saving time was over and we were on standard time, then you would subtract 5 hours. So 11:51 minus 5 would be 6:51 a.m. Eastern Standard Time. All right, the next group, 02007 KT. The 020 is the cardinal wind direction, which in this case is north-northeast. Think about a compass where 0 is north, 90 is east, 180 is south, and 270 is west. And so 020 is 20 degrees to the north, or I'm sorry, 20 degrees to the east of being due north, okay? So it's a northerly breeze, slightly north-northeasterly, okay. And then the 07 KT means that the sustained wind speed is 7 knots, okay? And what is it, one knot is equal to 1.15 miles per hour. So the bigger the difference, or the higher the number, the greater the discrepancy between knots and miles per hour. Okay, 10 SM, that means the visibility is 10 statute miles, not nautical miles, but statute miles, the kind of miles that we all deal with. Okay, then you have FEW 080. Well, there are 5 classifications for sky cover. Clear is there's no clouds anywhere. FEW, which is what you see here, means that 1/8 to 2/8 of the sky is covered by clouds. So you're dividing the sky up into octants, if you will. Scattered would be 3/8 to 4/8 of the sky covered by clouds. Broken, 5/8 to 7/8. And then OVC stands for overcast. So in this case, 1/8 to 2/8 of the sky covered by clouds, and the 080 is the height in feet above ground level, and you have to add 2 zeros at the end. So 080 plus 2 more zeros gives you 8,000 feet. Then the next one, same amount of coverage, but it's now at 11,000 feet, okay? And then finally, the third layer is at 25,000 feet, and it's broken, which means it covers 5/8 to 7/8 of the sky. Next, the temperature, or 1/8/1/6. The 1/8 is the temperature in degrees Celsius, okay? So to convert that to Fahrenheit, you take 9/5 or 1.8 times that number and then add 32, and you've got your Fahrenheit reading. It's about 64. And then 16 is the dew point temperature in degrees Celsius. So I'll throw this in here real quick. This is simply a personal technique I came up with, which helps me to make a quick conversion between Fahrenheit and Celsius and back and forth. So if you know that 0 is 32, 0 Celsius is 32 Fahrenheit, and you know that for every 5 degrees you go up Celsius, you're going to go up 9 degrees Fahrenheit, okay? So think about it. You've got 0 and 32. This goes up 5. This goes up 9. So now you're at 5 and 41. Let's do it again. 10 and 50. Okay, I think I may have reversed hands there. 15 and 59. 20 and 68. Okay? So if you know that 15 is 59 and 20 is 68, 18 is just to the high part, or the high end of middle, okay? So if you think about that, if you're going from 59 to 68, 64 would be just past the halfway point, and that's what it turns out to be. So you're never going to be more than a degree off by doing that type of conversion. But again, you start 0 and 32, you know the one goes up 5, the other goes up 9, and you've got your conversion. Okay, A3017, that is the altimeter setting, and you put a decimal point between, or in the middle of those 4 digits, and this is what pilots use to make sure they know how high they are off the ground. It's very critical information for them to make sure that they don't crash or never land. And for us, this is basically what your home barometer would read. If you had a home barometer hanging on the wall, it would read, in inches of mercury, which is what that is. Okay, now the next one is RMK space A02. Well, RMK stands for remark, and A02 means the station is equipped with precipitation discriminator sensor, okay? And that means that they have a sensor that is supposed to be able to differentiate between rain and snow and sleet and hail and all of this. There are still some times that it doesn't quite figure it out, and so the observation sometimes will have UP for unknown precipitation. I still personally feel like the only way to do that is to have a human being there, but that's just my opinion. And if it's A01, that means the station does not have that type of equipment. All right, SLP 212. SLP stands for pressure reduced to sea level, okay? If we didn't reduce the pressure to sea level, all the lows would be over the mountains and all the highs would be over the ocean, and we don't want that, okay? We want to know where the weather systems are, so we have to adjust everything to a standard so that we can actually see where the lows and the highs are. So SLP stands for sea level pressure, and then 212 is the sea level pressure actual reading, which is 1,021.2 millibars. Now, I don't know who came up with this, I'm just passing it along. If this number, the 212, if the number is less than 500, you put a 10 in front of it. If it's more than 500, you put a 9 in front of it, and you always put a decimal point before the last digit. So 212 is less than 500, so you put a 10 in front of the 212, you put a decimal point before the last digit, and you get 1,021.2. If that was 712, and it was greater than 500, then you would put a 9 in front of it, and it would be 971.2, okay? And that would, if you had a hurricane approaching you, that might come into play. All right, the next group, 70028. 7 stands for the 24-hour precipitation amount ending at the time of the observation. And 0028 is 0.28, 28 hundredths of an inch in the last 24 hours. Always put a decimal point before the last two digits. Moving on, T01830161. The T stands for temperature. Now, this is simply more detailed data over what we looked at before. You remember back in here, we had 18 and 16? Well, this rounds it off. And I got into trouble on this several years ago when we were going through a hot spell, and an observation came out, a special in between hours, that had that converted to 106, and I thought, oh, we just broke the all-time record. I have to, post about that. Well, it turns out that if you got it down to the tenth of a degree, then it was only 105, and then I had to retract that statement. So these detailed readings are really, really important, especially when you're looking at records. So the 0 right after the T means the temperature is above 0, okay? If it's 1, then it's a negative number. So it's a positive number, and then 183 stands for 18.3 Celsius, decimal before the last digit. And then the dew point, 0, again means it's above 0, and then you have 161, and the dew point temperature is 16.1 degrees Celsius. Next, the 1 group is the maximum temperature in the last 6 hours, okay? And 0, again, means above 0, 1 is negative. 206 means the maximum temperature in the last 6 hours is 20.6 degrees Celsius. The 2 is the minimum temperature in the last 6 hours, and that turns out to be 17.2. And then the last group is the pressure tendency group. And the 5 tells you that that's what the data pertains to. But then after that, you have a 3, which is one of many, many, many pressure tendency descriptions. And the amount of the pressure tendency is the last digit, which is 024, decimal point before it, and 2.4. Now, the 3 means that, if I'm remembering this correctly, well, I'm going to check it out right now. This is the code, all the different codes, all 8 of them, for pressure tendency. Now, we had a 3, and so that was, the pressure is now higher than 3 hours ago. It was decreasing or steady, then increasing or increasing, then increasing more rapidly, okay? So you go all the way from increasing, then decreasing. All these are the pressure is higher now than it was 3 hours ago. This is the same, and this is lower. But all of these descriptions here give you more detail about how it got lower, or how it stayed the same, or how it got higher, okay? And so the 3, again, is in this group right in here. All right. Now, there are some other things that could come into play if you have precipitation or a thunderstorm present or whatever. So this is, just before I recorded this, these are raw observations from the Myrtle Beach airport. And the one on the bottom is a standard observation, okay, at 53 minutes after the hour. And then the 2 above that are what we call special observations, which means that something has changed from what was going on at the top of the hour. So TS stands for thunderstorm, and BR stands for mist, okay? So they've got a thunderstorm and some mist, but not actually any rain falling. Then over here, LTG, distant southwest to north. That means they're seeing distant lightning all the way from the southwest part of the sky to the north part of the sky. And again, if you can see the lightning and you can't hear any thunder, then that means that the lightning is so far away that the sound never gets to you, okay? It just goes over your head. But if you hear thunder, then that means that the lightning is close enough that it could, in theory, hit you. Okay, RAB 14E52. That means that rain began at 14 minutes after the previous hour and ended at 52 minutes after the hour. And this observation was taken at 53. So it ended 1 minute before the observation. And then the P0009 means how much precipitation fell since the top of the last hour. And then the 6th group is the 6-hour precipitation amount, which happens to be exactly the same, okay? Now, in the special observation, it has visibility 1V5. That means the visibility is varying between 1 mile and 5 miles. And then we're into the next hour now, okay? So the P0003 means how much rain has fallen since this time, okay? And then at the very top, and this observation was taken at 31 minutes after the hour, rain started to fall again at 22 minutes after the hour, and again, the amount was 300ths, okay? So apparently it wasn't enough to increase the 03 from the previous observation because it had just started 9 minutes before the special time of the special observation. Okay. Oh, now, do you want to know how many different abbreviations there are for METAR reports? 154. Now, not all of them are weather related. Some tells you some other types of information, but there are all the abbreviations there. That's page 1, page 2, and page 3. Okay? So, and you can see, like here, that SCT is scattered. We already talked about that. SFC is surface. SH is showers. SLP is sea level pressure. SM is statute miles. Over here, SN is snow. SP is snow pellets. SQ is squalls. STN is the station. VA, volcanic ash, and on down the list. So, that is a very in-depth look at how information from these various airports all around the world are coded, and then that information is sent to us, and then we can look at those observations, and thankfully we do have computers now that will plot those observations for us, although I would argue that when you had to do it all by hand, by the time you got done plotting that map, you knew that data. You really did. And when something does it for you, I swear sometimes you miss details. And but it takes longer to do it by hand, obviously. So it's a pro-con thing. All right, that's it for now. That is bonus weather video number 2 for this week. Number 3 will be upper air observations and how they're coded. That's even more fun, and that'll be on Friday. So y'all take care, folks. We'll talk to you soon. See you later.